Here's the answers. 21884 polonium becomes 21885 astatone plus an electron plus gamma ray and an anti-neutrino snake in the basket. Note 84 goes to 85 because the neutrons become a proton but the mass numbers stay the same. And then this one here, thallium 207 stays the same, but 81 become 82. So the thallium will actually become lead. You got your electron, you got your gamma ray, and you got your anti-neutrino there. Thank you, answers. You're welcome. Hooray, let's get on with it. How many alpha particles are released when one atom of uranium-238 becomes lead-206, and how many beta particles are released? Now this is great. This is a process of deduction. Let's see if I can turn this phone around so that maybe you can see the book. I enjoy this style of question. How does that look? Got my page? You do. There's my page. Okay, so you've got uranium. I might use blue pen so you can see the answer. 238 uranium with an atomic number of 92 becomes that's going to become lead 206. Lead has got 82 and that's Pb. So when you compare the mass numbers, and that's the first thing you do, 238 take 206 will equal 32 atomic mass units. Now that's always going to be divisible by 4, which will be your 4,2He alpha particles. So this will tell you how many alpha particles there are by looking at the difference between these two mass numbers. Remembering that the uranium steps through several elements before it gets to the lead, and that's because it's going from an unstable to a stable isotope. So you get 32 and you divide it by 4 and that'll equal 8, which means therefore there's 8 alpha particles. Now remembering that an alpha particle is 4,2He, so you're going to expect that whenever an alpha particle leaves, 2 protons are going to leave with it. Now if you got 8 alpha particles, then that means that you're going to have 8 lots of 2 protons leaving, which means that you expect 16 protons to leave the nucleus. But then when you look at the atomic numbers here, you've got 92 and you've got 82. Now if you do 92 take 82, you end up getting 10. But 10 is not 16. So, okay, sure, we've preserved 10 of the protons, but then somehow we seem to have gained 6. Where did the other 6 come from? Because they should have left with the alpha particles, but they still seem to be sitting inside the nucleus of the lead. Well, that's done by beta emission, where the neutron becomes a proton. So in this case here, and then it releases the electron. So in this case here, you look at the difference between them and you go, well, that's 10 and that's 16. Therefore there's 6 beta minus particles released. So 8 alpha, 6 beta. And now you say, how many gamma particles are released? Well, no one actually knows, because you have to measure, I guess, the amount of gamma particles. You can't look at the atomic number or the atomic mass and determine the energy states of nucleuses. So hooray, there's the answers.